All right, Advanced Math 8, here we go. We got lesson 6.1.4, solving word problems by writing equations. Okay, here we go. 6-31. We're going to match the mathematical sentence with the translation. So I've got a whole bunch of sentences over here, and then we're going to match it with the translation, the equation that goes with it. Okay, so the first one says, a zoo has 2 fewer elephants than zebras and 5 times more monkeys than elephants. The total number of animals is 30. 30, that doesn't help. They all have 30. Let's see. 2 fewer elephants than zebras. So that should be z minus 2. Does anything have z minus 2? Ah, here we go. So this must be zebras. And then this must be elephants because it's z minus 2 because it's 2 fewer. What's this one? 5 times more monkeys than elephants. Okay, elephants was z minus 2. Okay, I'm seeing what's going on here. This is elephants. Elephant. And then monkeys is 5 times the elephants. And elephants was z minus 2. So this must be monkeys right here. Okay, so that's the first one right there. Okay, so these two go together. This one is C. All right. Next one. Zola earned $30 by working 2 hours and receiving a $12 bonus. 2 hours and $12 bonus. I think it's this one. So Z must be her hours there. So 2 times her hours plus 12 is her bonus equals 3. So this one must be A. All right, 2 for 2. This one says 30 ounces of metal. Okay, I see what they're doing. 30 every single time. Seriously? Yep. All right, so the number of ounces of silver needed is 12 times the amount of zinc. All right, so 12 times zinc. This has to be this one. Well, no, I think it's this one. So 12 times zinc plus the zinc. So this must be silver plus zinc equals 30. It's got to be this one. So this one's going to be D. Last one. Eddie, who earns $5 per hour, worked 2 hours longer than Zach. Okay, so 2 hours more than, of course, it's going to be Z. So longer means more. Okay, see here, here's the Z plus 2. So this is Eddie's hours right there because it's 2 more than Zach. And he earns $5 per hour. So 5 times Z plus 2. Okay, I see what they're doing there. And then Zach is earning $12 per hour. So here's 12 times Zach hours. And this is Z plus 2 represents Eddie's hours right there. So that's going to be B, of course. All right, so we are going to do what's called a let statement. A let statement is where we write down what each variable is going to be representing in the problem. So up here, I saw that this one, I had a Z, and we're going to let Z equal the zebras. Makes sense, right? So let Z equals the number of zebras. So we're going to let Z, so this is for number 1. Let Z equal the number of zebras. We want to use units, and our units is just number of for this one. In number 2, we had a variable. The variable was also Z, but in this case, this was Zola working hours. So Z must be representing the number of hours that Zola is working. So we're going to say that let Z and that one equal the number of hours Zola works. So our units there is going to be in hours. In the third one, we've got 30 ounces of metal is created by mixing zinc with silver. All right, so in this one, we've got ounces of zinc, and then this is ounces of silver because it's 12 times zinc. So we're going to let Z be zinc in this one, and it's the ounces. All right, the last let statement, again, it's Z, but this is Zach, And this looks like they're doing hours on this one, right? So it's 2 hours longer. So let Z on this one equal Zach's hours. Oh, I can't spell Zach. Zach's hours. Okay, so a let statement is just something that we're going to write down to help us keep track of what the variables mean in the problem. 6-33. Elsie took all of her cans and bottles from home to the recycling center. Good for you, Elsie. The number of cans was 1 more than 4 times the number of bottles. That sounds confusing. She earned 12 for, that's the wrong kind of 4. Bad. All right, for each bottle and 10 cents, or 12 cents for each bottle and 10 cents for each can, and ended up earning $2.18 in all. How many cans and bottles did she recycle? So we want to find out the number of cans and the number of bottles that she recycled. So there's a couple of ways that we could do this one. Solomon comes along and he's like, you know what? I want to solve this with just one variable. So I want to write this thing out so it's only going to have one variable in the problem because I don't like 2 variables. Well, okay, that's fine. So we've got 2 different things in here. We've got bottles and we've got cans. So if I'm going to have only one variable, that means I have to choose to use bottles or cans as my variable. Now here it says cans was 1 more than 4 times the number of bottles. So cans is compared to bottles. So that means bottles should probably be our variable because cans is being compared to it. So if I wanted only one variable, I would say let B, let's say B, equal the number of bottles. Okay, so we start with a let statement. B is going to be the number of bottles. Now that means the cans, we're going to have to write in terms of bottles. Now it says the cans was 1 more than, that means plus 1 at the end, 1 more than 4 times the number of bottles, and number of bottles is B, so 4B. So the cans is 4B plus 1, so it's 1 more than 4 times the bottles. So here we have only one variable, bottles, and then cans is in terms of bottles, 4B plus 1. So we're going to write the equation now. So the bottles were 12 cents a piece. So I'm going to say 0.12 times bottles. So 1 bottle, each one is 12 cents. And then I'm going to say plus 0.10, so that's 10 cents for each can. And cans are 4B plus 1. And that's going to be equal to, I don't know why I wrote so small. I did. The total amount of money that they got, $2.18. Next part. Solve Solomon's equation and answer the question with a complete sentence. Okay, so I got to solve his equation. All right, so this is 0.12b. I'm going to distribute this 0.10. So that's going to be plus 0.4b. And then distribute 0.10 times 1, so that's 0.10. So 0.1. And then it's equal to 2.18. Really don't like all these decimals. Can I get rid of them? Yes. Let's multiply everything by 100. So let's multiply both sides by 100, and then we don't have to worry about all these decimals being all over the place, which are kind of really bringing me down right now. So I got 100 here, 100 there. So I've got 12b. 100 times that, it would be plus 40b. And then plus 10 is equal to 218. That's better. I don't have so many decimals messing the place up. All right, so combine my like terms. I've got 12b and 40b. That would be 54b. plus 10 equals 218. Subtract 10 from both sides. So I get 54b is equal to 208. So how many times does 54 go into 208? That's an excellent question. Let me pull out a calculator. 54 going into 208. 3.85, blah, blah, blah. What? Did I do something wrong? What did I do? 12, 40. Dang it. This is 52. Why did I do 54? I don't know. Anyways, this is 52, so that's why it was coming out wrong. I'm not even gonna try to redo this. I've gone too far into the video now. So I've got b is equal to 4. Wow. I will say this, it's like almost 5 o'clock on Friday. I should be home right now. Anyways, I get that there are 4 bottles. Now the question was, how many cans and how many bottles did they recycle? So I don't really have the whole answer here. I only know that there's going to be 4 bottles. But since I've done this whole let statement up here, I now know that cans is 4 times 4 plus 1, because bottles is 4, right? So 16 plus 1, that means that there are 17 cans. So answering the question, she recycled 4 bottles and 17 cans. Done. All right, now Marcus is going to get a little tricky with this. He's like, I'm not going to do 1 variable. I'm going to do 2 variables. Boom, Marcus. Way to go. Respect. So his let statements would be let B equal the number of bottles. And he's going to say let C equal the number of cans. And here's how we're going to write his equations. So he's going to have the equation that up here when it says the number of cans was 1 more than 4 times the number of bottles. So that means that the cans we can write as C equals 4B plus 1, because cans is 1 more than 4 times bottles. So there's our first equation. Our second equation would then be 0.12 times the bottles plus 0.10 times the cans equals 2.18. So if I have 2 variables, I have to solve it with 2 equations. 1 equation is not enough. There's just too many different answers out there. All right. So there we have that. Do we have a different equation? Yes. Should we get a different answer? No. These 2 equations both represent the same exact problem. So do they represent the same problem? Yes, they do. If they represent the same problem, then they must also have the same answer. So now we're going to show that this is going to be able to give us the same answer of 4 bottles and 17 cans. How are we going to do that? Here's how we're going to do it. We're going to we're going to combine these 2 equations together. Here I know that C is equal to 4B plus 1. And then over here I had 0.12B plus 0.10C equals 2.18. Well, I know that cans equals 4B plus 1. So what am I allowed to do? Instead of C, I can just say 0.10 times 4b plus 1 equals 2.18. And what do you know? We're back to the same exact equation that we had when we did it with one variable. And so we know we're going to get the same answer of 4 bottles and 17 cans. All right, halfway done. If I can find the second page. Yes, here it is. Okay, so Solomon has some electronics. His parents said he could recycle. More recycling. Marcus has permission to recycle some small household appliances. Okay, so we've got electronics and we've got household appliances. Sweet. They looked online and discovered that the local recycling center offers 60 cents per pound for the appliances and $1.50 per pound for the electronics. But there's a $27 hazardous waste fee that has to be paid to, wow, I wrote to be paid twice. All right. That has to be paid to recycle electronics, no matter how much you recycle. All right, we're going to write separate equations for Marcus and Solomon. Let's start with Marcus. What's he doing? Marcus is doing household appliances. So he's going to, we're going to let, we're going to do M for him. What do you think? M? No, we should really compare the number of, oh yeah, so we're supposed to use the number of pounds each would have to recycle to receive the same amount of money. Oh, so it's telling us what our X and Y should be. I really need to go home. So let's let X equal the number of pounds, so the weight, of recyclables. I can't spell. Recyclables. And we'll let Y equal, and that's going to be the money, right? Yes, the money paid out. And we're going to say that's going to be in dollars. All right, so let's look at their two different situations. So when we have Marcus is just going to do appliances, right? They looked on. Okay, Marcus is doing small household appliances, so that's 60 cents per pound. So Marcus, he's going to have Y equals 0.6 times the number of pounds. So that's going to be his, the money he's going to get is 0.6 times X. There you go. The next guy, he's going to get more money per pound, but he has to pay $27 because there's a waste fee for electronics. So who is that? Solomon? Yeah. So Solomon, he's going to get $1.50 per pound, but we have to subtract out $27 because he has to pay a fee, right? Now we want to find out what is going to be our equation to solve when they make the same amount of money. Now the problem here over here with Solomon is he's going to have to recycle a whole bunch before he can make his money back because he has to pay this $27 for the waste fee. So he's out $27. So he's going to have to recycle a lot more. Okay, so but this guy over here, Marcus, he's just got gravy right from the start. He's going to make money. He doesn't have to pay a fee. All right, so we want to know, when do they receive the same amount of money? Same amount of money? That's Y. Y is the same amount of money. And Y is equal to these two things right here. So what should we do? We should say 0.6x should equal to 1.5x minus 27. Because this here is Marcus, this is his money, and this here is Solomon, his money. We want to know when do their monies equal each other. So I'm going to say 0.6x. When does that equal 1.5x minus 27? Okay, so I would probably subtract 1.5x from both sides. Cool. And I get negative 0.9x equals negative 27. Don't like that decimal in there. Let's multiply both sides by 10. So we're going to get negative 9x equals 270. So I just multiplied both sides by 10. Now it's looking a little bit better. It's negative 270. I'm going to divide by negative 9 on both sides and get x is equal to 30 pounds. So 9 goes into 270 30 times. So now I know that the pounds, because X is the weight of the recyclables, see, that's why these let statements are helpful. So I know X is the number of recyclables, so there should be 30 pounds of recyclables. Now, how much money would that be? Well, all I need to do is plug that in to either one of these equations. So all I have to do is 30 times 0.6. And 30 times 0.6 should be what, 18? Times 0.6, yep, that's 18. So all I have to do is say, okay, then y equals 0.6 times 30, and y is 18. So what does that tell me? It tells me at 30 pounds, they'll both make $18 because X is the weight of the recyclables and 18 is the amount of money they're being paid. This is the 1 poundage where they get the same amount of money, 18. So our answer would be 30 pounds, and they would receive the same amount of money, which is 18. So that's why these let statements are really helpful, because at the end of the problem, we just have these variables, and we're like, oh, what does that represent again? Well, now I know what it represents because I wrote it down over there. All right, we got 3 more of these. Morgan decided to take a bike ride before it got too hot. Good idea. She left the campsite and rode her bike at a speed of 16 miles per hour for 1.5 hours. How far did she bike? So I'm looking for distance. Now we've done some problems like this where we could have done it as a what do you call these? Conversion. So miles per hour, and then we want miles. So if I multiply on this one by 1.5 hours, we see that the hours cancel each other out. So 16 times 1.5, let's see, that'd be 16 plus 8, right? So that'd be 24. So we get 24 miles. Okay, next. Morgan's dad went to get groceries at the camp store at the bottom of the mountain. He drove 20 miles per hour for 0.4 hours. So he's got 20 miles per hour. And he's going to go 0.4 hours. So I'm going to just multiply by 0.4. This is hours. So hours reduces, and I end up with 20 times 0.4 should be 8 miles. Okay, when Morgan's dad returned from the store, he went for a jog. He jogged for 1 hour and 15 minutes at a pace of 4.8 miles per hour. Okay, so he went 4.8 miles per every 1 hour. Now look at our units. This is 1 hour and 15 minutes. Well, I need to change that into units where it's all hours because my units over here is hours. So I'm going to multiply this by 1.25 because 15 minutes is a quarter of an hour, or 0.25. So multiply that by 1.25 hours. And who runs for an hour and 25 minutes? That's crazy. All right, I only run if somebody's chasing me. So 4.8 times 1.25, we end up with 6 as our answer. So again, hours are canceling, and we get 6 miles. Good for him. All right, so in problem 35, what 3 units of measure did all 3 parts have in common? Well, we had a rate, and our rate was in miles per hour. We had a time, and time was in hours. And our answer was a distance, which was in miles. So all 3 of these problems had rate, time, and distance. Now, what was happening with rate and time? Rate and time got multiplied each time, and that gave us distance. So that we can write a model for this of distance equals rate times time. I call this dirt. Dirt! D equals R times T. So rate times time equals distance. That's what we found up here each time that we took the rate times the time. It gave us the distance. So D equals rate times time. Taylor, Morgan's older sister, will be driving from her house to the campsite tomorrow. She averages 65 miles per hour for the trip. So that's a rate. So her rate is 65 miles per hour. And it is 195 miles from her house to the campsite. That's a distance. Use the equation in part B to find how long she travels. We're going to use dirt. So the equation is D equals R times T. So we've got 195, that's my distance, equals the rate of 65 times time. So to find time, it looks like we will just be dividing by 65, which should be 3, right? Yeah, I think it is. I'm pretty sure it is. It is. All right, so we get 3 hours. Divide by 65, and T is equal to 3. Really close. I can almost go home. All right, while camping with her family, Morgan took her puppy to the river. Oh, that's sweet. The river has a current of 27 feet per minute. The puppy paddled upstream at a rate of 44 feet per minute in still water for 8 minutes. How many feet did the puppy swim? Oh, this is a little bit difficult. So we've got a river going here. Ooh, there's our river. Yay. So the river's current is going this direction. Okay, so there's the river's current. And the river's current is 27 feet per minute. So 27 FPM, feet per minute. Now the puppy is going to be swimming, and it says upstream. Upstream means going against the current. So the puppy is actually going this direction. And the puppy is going 44 feet per minute. 44 feet per minute. So that says that's how fast he's going in still water. Well, this is not still water. This stream is going against him. So the puppy's rate of speed has to have the current subtracted from it. I've been sitting too long. The lights just went out. All right, so the puppy's rate of speed is going to be its rate minus the current because he's fighting against that current. He's not actually going to go 44 feet per minute. This 27 is working against him. So here's the puppy. It's going to go distance equals its total rate is going to be R minus C. So the puppy's rate minus the current that he's fighting against, and then times time. So we want to know how many feet. That's a distance. We want to know D. So his distance is going to be the rate of the puppy, which is 44, minus the rate of the river that it's fighting against, 27, and then times time. Now remember, we have to keep it in the same units, so it's feet per minute. So this is 8 minutes. Okay, so that's okay. The units are matching up. All right, so 44 minus 27 should be 17. Yeah, 17. and then we're going to multiply by 8. So this is going to tell us how many feet, because remember, D is in terms of feet. So this is going to be 17 times 8, which comes out to 136. So D equals 136 feet. All right, we're almost there. Taylor and Morgan would like to spend some time on the river while camping with their family. The Taylor wants to rent a 2-person kayak. The cost to rent the kayak is $8 per hour and a $5 setup fee. All right, so the cost is equal to $8 per hour. So the total cost equals $8 per hour plus that setup fee of $5. So this is what a kayak costs. Now over here, Morgan sees this sign and she sees, oh, it's got a setup fee of $9, but look here, it's only $6 per hour. So she says, you know what? It's got a bigger setup fee, but it costs less per hour. So you know what? There's going to be a time when they would be the same. So maybe if we figured out that time, if we plan to rent it for more than whatever hours that is, the canoe would actually be cheaper. So that's what Morgan notices. If they rent it for a long enough period of time, the canoes are cheaper. So let's look at the canoe. Canoe. Doesn't look like it should be canoe. Why do we say canoe? Canoe, shouldn't that be C-A-N-O-O? English is dumb. So anyways, the cost for the canoe, or the canoe, would be I'm getting lost because I'm thinking about canoe. 6 times the hours, and then plus that setup fee of $9. All right, let's find out when the cost will be equal. So the cost of the kayak is 8H plus 5. The cost of the canoe is 6H plus 9. When are they going to be equal? Let's solve it. We'll subtract 6H from both sides. So I would get 2H plus 5 equals 9. I would subtract 5 from both sides and get 2H is equal to 4. It looks like 2 hours. So at 2 hours, the canoe is 12. And if I plug 2 into the kayak's formula, I get 16 plus 5. Wait, 2 hours. 2, 12. Oh, $2. Yeah. So the rental fee is 12 plus the $9. Forgot about that. So at 2 hours, here we've got 2. So I got 16 plus 5. So that'd be 21. And 2 hours here would be 12 plus 9, which is also 21. So 2 hours, we notice that they have the same cost. What is the same cost? Well, if you plug in 2 to both of these, so you get 12 plus 9, 21, and then 16 plus 5, 21. So at 2 hours, they both cost $21. I got thrown off here because I forgot about the $9 rental fee. So $12 plus the $9 fee, $21. There we go. All right, that's all I got for you. That was a long one. Sorry about that. Enjoy. I'm going to go have a weekend. See you later. Bye-bye.